it looks like a normal Windows file name. Sort of they get the win for file name choice. It targets Windows platforms. Now the key features, I'm not going to talk about that because Jibran's going to demo all of those for you in a couple minutes. But I'm going to talk a little bit about the environment. This was a Miami sports bar. It was an elite location, had a lot of celebrities that frequent that location. The IT operations was outsourced to a third party. This is not uncommon. Most organizations below normal enterprises outsource everything, and so they have really no ability to manage these systems themselves. So they're going to outsource it to another company. When we talked to the owner, we talked to them and asked them about security, about what they do with their systems. He basically said he was getting notices from his bank about online security and compliance, and he basically gave him a headache, so he just basically tossed him in the garbage. He basically admitted that to us. And then the other sort of byproduct here is that the point of sale system was also the sports bar's DVR. It was also the DVR server. So if you ever wonder what goes on in a Miami sports bar after hours, you really don't want to know. If you sit in a bar and you see sort of this long, flat, hard, sturdy bar, and you're sitting there having a drink and eating some food, if your fry falls off the plate, the 5-second rule does not apply. So now we're going to jump into some demos.
All right. So can everyone hear me okay? In the back? All right, so are you all ready for the demos? We've got about 4 demos, and I want you to say, hell yeah, if you are ready for the demos. Are you ready for the demos? Yeah. Am I ready for the demos? No, I gotta move this cup. All right, so without further ado, let's go into the demos. Okay, so the first sample I have is, it's called the memory rootkit. So as Nick mentioned, a lot of malware, now that databases are getting encrypted, we can't really do just smash and grab. So what the attackers need to do now is basically maintain persistency in the system, and they basically dump the memory where the data resides unencrypted. So you guys are very lucky. You guys are going to see an actual malware that is going to install itself as a rootkit and steal data from the memory. So without further ado, let's go on to it. Let's see, is the resolution okay?
Yep, it's fine.
Yeah, okay. Okay, so I'm going to go to the folder that has the memory rootkit malware. I call it memkit. And let's actually see what samples it has. So it's got a loader.exe, which is basically a file that loads the rootkit into the kernel. Then you've got ram32.sys. And actually, you know what? This demo is going to be really interactive. We really planned prizes for you guys, but we lost all our money in blackjack last night. So the most we could do is give you a Twitter mention if you answer a question. So ram32.sys. Who wants to take a guess what this file could be? This is actually the actual rootkit that gets installed, and searcher.dll that has the track data expressions and whatnot to enable to search the data on the hard disk. So let's actually see what loader.exe is all about. So I'm just going to run a strings command on loader.exe, and I'm going to show you what it has. So as you can see, the usage of this, attackers, they program really neatly too. So they have like a whole usage area in the program. I is to install the system driver. It must be in the current directory, so they're helping us out as well. R is to start and resume the capturing. So if you have the malware on the system, if you want to start or stop, there's an option right there. S is to stop the capturing, and U obviously is to uninstall. And they also tell you, hey, it doesn't uninstall until you reboot. So pretty helpful there. Okay, so what we're going to do is just load this rootkit into our kernel. So as you can see, loader.exe, I just give it an I switch, and it installs ramsys32 driver. Now we want to run this. We want to start this, right? So loader.exe R. So far so good? All right. So now we're going to go to this Windows folder where malware actually dumps the files. So I'm going to sort my files by date modified, because the file should be created right now. As you can see, we don't see any files. So what I'm going to have to do, and actually, can I let you guys answer this? What do I need to do here? Show it in files. All right. You guys are on this, all right? Okay. And I'm going to sort this by date modified again. Oh no. No, it's not the demo. There's one more thing that the malware has. Anyone wants to take a guess of what that could be? There you go. You're getting a Twitter mention. All right, so we go to view again and we uncheck this box, hide protected system operating system files. We do that, it gives us a warning, but what the hell? Just go with it. Okay, so now we see a weird looking file. Can everyone see it? 7152, whatever the random digits are. And it's 0 KB right now. So why it's 0 KB right now? Because we haven't sent any data to the memory for the malware to attack. So I'm going to open this file in TextPad, favorite text editor. And all right, are you part of the team? Okay, so right now there's no data there because in the memory we haven't processed any track data. So what I'm going to do is I am going to go to my pending payments folder, and I'm just going to open some checks. So this is basically, these are basically the temporary files, like when you swipe your credit card at a bar, at a restaurant, at a hotel, these temporary files get created, but just for a very tiny, maybe a millisecond, and then it goes to the database. Or it just goes to the memory and then to the application to the database. So these are some files that I'm just gonna load up in my memory just to kind of see what's out there. And basically, in my all transactions, I'm going to say, since we don't have a real point of sale program, I'm going to say all payments processed. All right? Cool. All right, so I save this, and now we go back to this file, and TextPad. It's alerting us that, hey, some application has updated this file. Now, we didn't write anything to the file, right? So it's got to be the malware that did the job. So we're going to reload it. And here you go. So we see credit card numbers, the names, and this is basically the pattern of track data, track 1 data and track 2 data. Now this malware has an additional feature. Now a lot of the companies are investing in DLP software and credit card data scanners. Who can tell me what's wrong with the track data format here? So there's one really tiny thing that this malware does. And it's a really neat feature. So if you see here in the first line, after these numbers, right before the tangent of dark tangent, we see a percentage sign. In track 1 data format, in the real data, in the real file that I opened, we see a caret character. Now this is actually a big indicator for track 1 data, and a lot of DLP software, they code this into them so to be able to detect track 1 data. So what the malware is doing is replacing all the caret keys and replacing it with a percentage sign, so if anyone's searching for track data, they won't get it. And you guys might be wondering why people don't just search for cardholder data. And that's because a lot of times when you search for cardholder data, you get a lot of false positive, a lot of noise. So a lot of people just search for track 1 and track 2 data. So that's one thing that they do. And then also if you look at the track 2 data, so in here there's an equals to sign, right? So guess what the malware does to the equals to sign? Damn right, they turn it into money, right? So that's basically how neat their output is. As you notice, my file, my actual transaction file had a lot of other stuff, but when the malware runs and it searches the memory for the data, it basically parses out just the track data and it puts it in this neat format. And the last feature of this malware that I want to demonstrate is that since Nick mentioned, they don't want to come in every time and rotate the files themselves, so it has an automated feature. So what it does at about 10 a.m. every day is that it changes the file. So let me change the file the system time to 9:59, and I'm gonna make it a.m. So right now we see the date modified 7/31/6/24. Right. So right when the clock hits 10 o'clock, this basically becomes 0 KB, and the new time is 10 a.m. So any guesses what happened to the data in this file? So this is our file. Now it's got no data. So what happened was this malware actually rotated the file and it created a new file with today's date. So it says S 2010 7/31, and this is the file that has all the data. So if I just do word wrap, you'll see the exact same data that you did in that file. So that's basically it for the memory dumper malware, and we're gonna move on to the next malware now.
Okay,
All right.
let's jump back into the presentation real quick. So this next piece of malware is basically a Windows credential stealer. So we gave it the code name Don't Call Me Gina. And you'll see when we're going through this why the file name is sort of a good choice as well. But again, the target platform is Windows. Now the victim here, just a little set this up a little bit. This was an online adult toy store. They had about a 100-person company. They had some stores as well, some physical locations. But they decided to outsource all of their hosting to a basically and development to a low-cost provider, and it was a sort of well-known provider. They found the information about that company in sort of the back of a tech magazine. It looked really great, and just like everybody else, when they're shopping for hosting providers. And basically, they found that there was remote desktop enabled, which basically was a terminal server. And so, just to set it up a little bit, the attackers were able to get into the remote desktop or system or the terminal server that was used by the hosting provider to get access to all the systems they were hosting. And so I'll set that up for you. And then one other piece is that at the end result, the attackers were able to then modify the adult online books on toy stores website so that it would query the database when you called a certain page, and it would dump all the latest transactions into a web page for them to then go and download. Now the attack itself from the Gina functionality, Jibran's going to demo that, but I just wanted to set it up and show you the first part of how they got in and sort of the end result. But the real meat of the malware is actually in the middle and what they're able to do.
All right, so we are ready for demo number 2. Are you ready for demo number 2? Oh yeah. All right. So by the 4th demo, we should be here on track 1. All right. So, all right. So this is actually one of my favorite malware, and actually this relates to all of us because a lot of us, if we don't use Windows XP computers, we touch it at some point in time because they're so damn insecure. But anyhow, so I'm going to show you the pieces of the malware, and I don't know why when I do it first time it doesn't do it. Anyway, so call it Gina, and let's actually see what's in this package. So we've got fsgina.dll. Now, who can tell me what msgina.dll? Anyone have heard of msgina.dll? We got. Yeah. So it's basically, it helps with the authentication process, right? So when you see that screen with your name on it and says, "Hey, come enter your password so I can steal it," that's MSGina or a slight variation of it. So FSGina is basically a variation of MSGina. It tries to get loaded with MSGina so that it could capture the passwords upon legit logins. Now FSGina.reg is actually an automated script. If I just run this, the malware is going to load in the registry. But I'm going to be nice enough and I'm going to show you guys exactly which key it changes in the registry. And this timestamp.exe, that is actually a piece of malware that actually changes the time of the malware files. So I'm going to copy these 2 files, fsgina and timestamp, in Windows System 32 directory. So what we're going to see is that these 2 files basically, they show up at the top, right? So a lot of times when we're investigating a Windows computer, for a friend or your mom or your grandmom, whatever, you basically go through to this task manager of a Windows System 32 folder, right? To check, hey, is there a malware infection there? So likewise, attackers know that, and what they try to do is basically try to hide their malware around the time when operating system was installed. So this timestamp utility actually does that for them. So I have this command here that is going to change it, but I'm going to tell you a reason why I chose this time, Saturday, 4/13/2008. It's not because it's my birthday, but it actually has a meaning. So I'm going to go to System 32 folder and actually check the time of msgina.dll. Now, if I'm a good malware author and I'm actually on the system, I want my fsgina, like the fake sgina, to have the same time as msgina. So it's basically 4/13/2008, 10:42 p.m. So what do the malware writers do? They do the same time. So if you notice right here, fsgina right now has date modified of 6/16 and date created of 7/31. Right when I run this command here, it's going to change the time. And look what it changed it to, 4/13/10:42. So yeah, now if